Good morning, children. Welcome back to ICAN Physics. Now, in this class, we are going to see about the classification of materials and the temperature coefficient of resistance. Okay. Good morning, children. Welcome back to the video classes. Now, we are going to see the next question. In the case of insulators, so according to the lesson 2, that is lesson 2, current electricity, the materials are classified into 3. One is conductors, second one non-conductors, and the third one semiconductors. Okay. So according to the resistivity, the materials are classified into 3. One is conductor, non-conductor, and a semiconductor. If the resistivity lies between 10 to the power minus 8 to 10 to the power minus 14 ohm meter, then it is called a conductors. Then for non-conductors, 10 to the power plus 8 to 10 to the power plus 12, then it is non-conductors. For semiconductors, then it will be 10 to the power minus 2 to 10 to the power plus 4. Okay. Here, when the temperature increases, then the resistance R also increases. For the conductors, the temperature increases, the resistance also increases. For non-conductors and semiconductors, when the temperature increases, then the resistance decreases. Okay. So now you can see the case. In the case of insulators, the non-conductors are otherwise called the insulators. When the temperature decreases, automatically the resistance increases. Okay. Then automatically we are having one word. Sir, what about resistivity? We are talking about only resistance. Here you can say resistivity. Here also you can say resistivity. So when the temperature increases, the resistivity also increases. When the temperature increases, the resistivity decreases. Okay. So what is the relation? The RT equal to R naught into 1 plus alpha T. Okay. So what is alpha? Temperature coefficient of resistance. Now the R naught is common to first term and second term. So 1 into R naught. R naught into alpha T. Alpha T. The plus R naught comes to this as minus. So RT minus R naught equal to alpha into R naught T. So the multiplication R naught T comes to this as division. So RT minus R naught divided by R naught T equal to alpha. Okay. Just you can define what is temperature coefficient of resistance. Temperature coefficient of resistance is defined as the ratio of increase in resistance per degree rise in temperature. Okay. So when we are subtracting the resistances, then automatically its unit is ohm. So in the denominator, we are having R naught, its unit is ohm, and the temperature, its unit is per degree Celsius. So ohm getting cancelled. So the unit of temperature coefficient of resistance is per degree Celsius. Okay. So this is by using resistance. The same formula can be written by using the resistivity. That is rho T minus rho naught divided by rho naught T equal to alpha. Okay. So here RT or rho T, that is the temperature at given temperature. The given temperature may be 600 degrees Celsius or 60 degrees Celsius or 70 degrees Celsius, whatever it may be. So then the R naught or rho naught. R naught. Here the naught defines 0 degree Celsius or 0 Kelvin. 0 Kelvin. So for instead of asking like that, they are asking at room temperature. At a room temperature. Then the room temperature may be given as 27 degree Celsius. 27 degree Celsius. Then we can modify the formula. So how we can modify the formula? RT equal to R27 into 1 plus alpha. Here how we write? T minus 0, then it becomes T. So that we can write T minus 27. T minus 27. So now do you get it now? Do you get it out? Okay. So finally we can change the formula for alpha. Okay. So alpha equal to RT minus R27. RT minus R27 divided by R0 into T. So R27 into T. So like that we can calculate the temperature coefficient of resistance. Okay. So the temperature increases, the resistance or resistivity are also increases. So it has only positive temperature coefficient. Positive temperature coefficient. So when we are going for non-conductors and semiconductors, when the temperature increases, the resistance decreases. After reaching a particular stage, it may go to the negative. So it may have negative temperature coefficient. Okay. So the material which has negative temperature coefficient is called thermistors. Okay, thermistors. So some of the materials having very low temperature coefficient. Okay. So when they are having low temperature coefficient, they are alloys. They are alloys. The previous class what we have studied in potentiometer and meter bridge. We are using manganese wire. Why we are using manganese wire? Because of this property. Because manganese is the alloy which has very low temperature coefficient and high resistivity. So because of this property, we are using manganese as 1 meter wire in meter bridge and 10 meter wire in potentiometer. Okay, do you get it now? Do you get it out? Not out.